Okay, everybody, so we're going to get started. So this discussion we're going to be using as a review, so I want to figure out what topics you're interested in hearing about. So who wants to talk more about pointers? 1, 2, structs. 11, 12-ish. The circular inclusion problem. Well, that's probably something we'll need to talk about, so it's like the homework problems that we just covered from last week. Hey, you guys actually did pretty well overall. Most people got their some references. Namespace. Containers. Okay. 7, 8. And curses. Okay, so what are you guys' questions on curses? Is it getting your program to compile? Is it getting your program, is it getting to compile? To run? So how to do stuff? Do stuff then. We'll talk about some of the other stuff first. So first couple things, right? If you want your program to be able to compile with curses, you need to make sure that you add the following lines to your CMake list. I want to use end curses. We're not plugged into the screen. There we go. Yeah. I am recording, yeah. So if you want to use end curses, say that you want to use it. Then you go find the package for curses where curses is living at on your computer, and it's required. You need it. You go and you create your executable just like normal with all your sources. This line right here is setting it so that I'm turning on the wall and the error options for my program so that I can get warnings and errors about things to do wrong. To then compile with curses, we need to target that library. So you need the name of your executable. Private means only you need it. Versus libraries, that's wherever they happen to be at. Then the target include directories, the name of your executable, private because only you need it, and then wherever this include directory was. These two guys over here are variables. They were set by the find package command. So they're initialized to have the values of where curses library is at and where the include directories are at. The link libraries are necessary so you can compile and actually call it. The include directories command is so that you can just specify like pound include end curses or pound include curses if you're using curses, and not having to specify where it actually lives at via its long name, like sys/lib/end curses or whatever. H. So when we have a curses program, first let's start curses. Then I don't want whatever I type to show up back onto the screen. So turn off echoing. And then cbreak makes it so that my input is available immediately. The next thing that I attempt to do is make a cursor tracked window, which is my own user-defined class. It's over here in the struct. It has a window pointer, which is a pointer to the curses window. And I'm also keeping track of at what row and what column is the cursor located at. Any questions on the struct? I then make a new cursor tracked window. So to do that, I make an instance of my struct. I then call the new win function. The new win creates a new window, and a new window is not like a new terminal. A window is like a partitioning of the screen. So like as an example, we can kind of think about like this screen has been partitioned up into 3 separate windows. One where my text is at for my my file, another window over here for listing all the files of my project, another window down here for the terminal, right? Still one screen, but it's been broken up into multiple different chunks. That's the point of creating windows, is to logically divide the screen into multiple parts. So the arguments to new win are the number of rows, how many rows do you want, how many columns do you want, and where do you want this window to be positioned at? Where do you want the upper left-hand corner to be? Does that make sense? Any questions so far? Okay. So let's go back to main. So I make that window, and then I'm going to go fill it up with stars. So here is my fill window function. I go through I equals 0, I less than the number of rows, the number of columns, and then I move the cursor to that position, and then I add the character on the window. So move W add char means on this window, go to this row, this column, and put that character there. I then move the cursor back onto this window at wherever I started at. Any questions here? Yeah. So W move, W, basically all the ones that start in red are the ones that are curses. Everything is not in red, except this is user defined, but pretty much everything else in red is in curses. Oh, so for your homework, for your midterm, it's going to be accepted on the command line, right? So on the command line, I'll pass you the size of the board that I want you to create. Yeah. It would probably be a parameter for like this function over here, right? Because I want to say like, how big do I want to base my windows to be off of? So if you followed the setup information, there should have been one of the packages that you installed for Sigwin, should have been ncurses. And like this get num rows, get num columns, it just calls the get max y and get max x functions that are defined inside curses. Any other questions about this so far? Hopefully it doesn't seem like super crazy madness. Pretty straightforward. I mean, I guess technically you could do it all as one window, but I think it's easier as 3 separate windows. Well, I mean, like, because not all the time do you change the contents of one window, do the contents of the other 2 change, right? Like the contents of the bottom window where you display somebody 1 only changes like once, right? The top one might change a lot because the people keep pressing the arrow keys, but it's not guaranteed to affect the middle window, right? The middle window only is affected when we put a piece on there, right? So not all of them are being updated all of the time, only certain parts at certain times. It could be. So when you make the size of that window, make sure it's larger than the number of, like that, make sure it's big enough to fit the entire print statement. Well, I mean, technically you could still do one window if you made it at least big enough to fit the entire print statement, right? and you only then used a portion of some of the rows and some of the columns, or some of the columns for the board area. But again, it's something that's easier logically to split it up into 3 distinct ones. Any other questions? So then we start playing our game. Or the keypad over here makes it so that we can get the keys, like the arrow keys, to move around. And then I refresh the screen. So take my virtual screen and put it onto the physical screen that's in front of us. Then for getting a valid move, we said that the way that we wanted to be able to move around was the WASD keys as well as the arrow keys. So we get a character from the user using wgetch. And then if it's W or up, I also had to AND it do a bitwise AND with the char text, so that I only got the actual key value and not any of the attributes that were there. Otherwise, it wasn't detecting it correctly. This just says keep the character portion of it, so key up only. This part right here checks to see that I'm not at the very top of the screen, because the students in the prior class, if they're like, if we're at the top of the screen, we press up, we don't want to move. So if we're not at the top of the screen, we're going to decrement our cursor row to mean that we moved up 1 level because the zeros are up higher. And then we move the cursor to that position using wmove. We repeat more or less the exact same concept for down, left, and right. Are there any questions here for moving the cursor around on the screen? And then finally, we had to get the user's input. Prior classes decided they wanted to press spacebar or enter to get the input. So spacebar or enter. And we also have to check that space the person's trying to put the piece on is blank, because we don't want you to be able to put pieces on top of somebody else's pieces. Right, that's cheating. So that says, hey, you can't do that. Then I get the row and the column that the person played on. And then I store the marker, either the X or the O, based on the current player's turn. Then I get back the move. If I'm not placing the move on the board, I refresh so that we can see the cursor move around on the screen. Yeah. So what's this piece of code right here do? Creates the string whose first character is X and second character is O. And then I index it at the position, which is going to be 0 or 1. Any other questions? Yeah. The question is refreshing the screen any different depending on how you've created your window, either new win, dir win, or sub win? They all get refreshed using W refresh. If you do create a window using new win or dir win, you want to touch the window first using like touch window. I also probably wouldn't recommend using dir win or sub win for your current assignment. Use new win. Anything else? Yeah. Three windows: play area, board area, print statement area. No. And then finally, over here in board, we have this function over here, which is going to be what's called to place the character onto the screen. So we update our internal state to reflect that that piece is there. And then I add a character to the window wherever it's at, move.marker. And then the cursor tracked window, I move my cursor so it's back at the location where I put it, where it started at. So that, because whenever you write a character to the screen, the cursor moves over by 1. So I want to move the cursor back on top of the piece that I just played. And then I refresh the window. Add character is over here. So we call move and add character when cursor row, cursor call to add. So add the character where I'm currently at. cursor tracked or move and add character is we set the window, the row, the column, and the character that we add. We then go onto that window, that specified position, and add the character, and then I make sure to update the cursor row and the cursor column. Does that make sense? I mean, hopefully, like seeing this code, it shouldn't be too intimidating. It should be like hopefully really, really straightforward to you guys, and like, oh well, yeah, that's not too bad. And it won't be too bad, hopefully, also when you're going and doing your project. And so now, if we play this game, I can move around. I can, oops, I don't want a breakpoint there. I can put my characters on there. And the game ends when 3 in a row are there. You guys have any more questions about curses or things you're not quite sure about? Yeah. So what I recommend for that question is to look at this piece of code, because all the winning stuff is over here in like win. I have an internal representation of the state of the game, which is different from what I have to display to the user. Those two things don't have to be the same. But doing things like checking for a horizontal win involved me just going to each row and seeing if the first character in the row was not blank. If it's not blank, check to see all of them are the same. Right? That's just how it's implemented here. What are the questions that are specific to curses? Yeah. Yeah. But any questions about curses that you're still not sure how to use? Hopefully it should be really easy. Do you have a question? No? So windows are, again, to logically partition your physical screen into multiple parts. So if you look at like the screen right now, right? How many screens do you see here? There's just one, right? Coming from the rejector. But you can see that the screen has been broken up into multiple different parts, right? These would be like the analogs of the windows, right? I want to use this portion of the screen to play the files. I want to use this portion of the screen to play frame content from the debugger. I want to use this portion of the screen for the variable display. This portion of the screen code. Right, so you can break up the physical screen into multiple logical segments where you can work at. Does that make sense? For tic-tac-toe, I just used one because it didn't make sense to have more. But for the other project, I had 3. Good question? Mm-hmm. Yeah, so for connect n, the number of pieces you need to win in a row is a command line argument. So they'll say like, I want to play on a road that's like, you know, X by Y big, and I need to get n pieces in a row to be declared the winner. You're writing the state of the screen, but if you try running any of like the stuff that I've given you, you should be able to look at the output for it and then be able to see what I'm asking you to do. Right? For example, this was the content of a game that I played earlier. And every time somebody pressed a key, I recorded what did the state of the game look like on the screen. So you can see that basically some of the times here at the beginning, it's like not moving. That's because I pressed keys that were like not movement keys. And you can see like as the time goes over, you can see how the game is progressing as pieces get dropped down. Then eventually the game ends with somebody winning. Does that make sense what's supposed to go in there? Correct. They log the screen every time anybody presses any key, and then also after the game ends. Huh? So what's actually happening with your question, because you're saying that I print everything at the end of the game. I'm not. I'm actually printing as the game goes along. But the way that files are set up on your computer is you tend to write to a memory buffer, right? Like, have you ever had like a file that you've been working on where you type stuff, but then you forgot to save it? You turned off the power and you lost what was there? Because it's not writing directly into the file. It's writing into memory. And then when you save, it actually gets pushed from memory onto the hard disk, the actual contents of the file. So the same thing is happening in the program. I'm writing to the file every time somebody like presses a key. I just put the screen. But because I don't flush the contents of the memory buffer to the file after I do that, which is like a slow process, the update doesn't happen immediately. So after the file gets closed at the end of my program, then all of the changes that I made will get moved from memory onto the file, and then you see them. Where'd that go? This is the wrong program. That's why. So if you go ahead and open the code that we have in class, again, it's online too, and you look inside this function, there you go. That's moving the cursor around. So it's already there. It's basically just, if the input key is what I'm looking for to move the cursor. Anything else? You write a cmakelist.txt, and you give me that with your source files, and then I compile it. Just like I did with the find determinant code. I'm not sure I understand your question, because like you have to take the source code, compile it into an executable, and that's what's runnable. I don't want you to submit to me an executable. I want the source code, and I want the CMake file, just like you did for the find determinant. And then test your code, I will run CMake to configure the setup. I will then run make to create the executable, and then I will run the executable on the program, or run the test on that executable that's created. Don't have to, but it makes life easier. You specify their size. So for example, that first row, right, where the user is able to move around in, how many rows big do you want it to be? 1. How wide do you want it to be? Whatever the number of columns is, right? Where do you want it to start at? Upper left-hand corner, so 0, 0, right? So you fill in those parameters to new window, boom, it gives it to you. So again, it would be something like the cursor tracked window. When you would call a new win, you'd say, I want 1 row, its number of columns big, I want to start at 0, 0, upper left-hand corner. Yes? So again, the terminology might be a little bit confusing here. There's one physical screen, right? I partitioned the screen into 3 separate windows, 3 separate areas of writing to. Right? Just like this screen right now is partitioned into like 2 separate areas, or maybe even more if we consider the headers up here. Okay, so let's put this screen up and we can talk about the other thing you guys were interested in. So the circular inclusion problem. So let's say we have a struct called we have a struct called brother, and in addition to everything that makes up a brother, the struct also has a sister pointer. Then we also have another struct, sister. And in addition to all the other things that it has a brother pointer. Let's assume that this file is in row.h. This file is over here in sys.h. Now, brother wants to use sister, so what's he probably going to do? Be able to use sister. Include it, right? And sister, right, wants to use brother, so what's she going to do? So we probably have a corresponding C file like bro.c. Right, we probably have a bro.c file, and he's going to include bro.h. What does pound include mean? Copy and paste. So we go over to copy and paste the contents of bro.h over there. But before we can copy the contents of bro.h, we first need to copy this.h, right? Because the first thing that we do in the copy and paste in that file is we go and copy and paste the other one. So we go and we copy sys.h. So this.h would pound include bro.h, but don't worry about them like in this infinite cycle of copying and pasting, because each of these files would have the guard there, didn't draw, and the guard would prevent it from like including forever and ever and ever and ever and ever. So we now copy the contents of sister.h, right? So she's like, I have a struct sys, right? And a struct sys has, in addition to all of its things, a brother pointer called bro. The compiler gets to this point of code, it's like, what's a brother? Right? Because if you look at the symbols that have been defined so far, have we ever mentioned anything about brother type? No. So the compiler, again, it goes only through it once and it goes from top to bottom. I have not seen a brother. This is an unknown type. Throws an error. Stops compiling. Right? You can see though that if we try to do like the include the other way, right? We go to inside sister, right? We include brother. Well, brother defines a term for sister, but we haven't seen sister yet because it's beneath us. Right? And so notice there's no way of being able to like put this definition of brother and sister in any way where one of the symbols doesn't exist. Does that make sense so far? Like we can't get this definition. So what you have to do to fix this is you have to throw in what's called a forward declaration, which is just a notification to the compiler that there is a type of this name and it exists. So what we would add over here after the .h would be a struct sister. And over here in sister, again below the pound include, we would say struct brother. Hey compiler, there is a type called sister. And you're just saying that it exists. And so now the compiler has seen this symbol now. And it's okay for it to compile through. If we go back over here, right, we want to include sister.h, and then sister.h we now would include that for declaration. So we would say we now have struct brother here. Oh, right, I'm able to build a system. Then we would have struct sister from pro.h. Okay, a type called sister exists, which is okay. It won't replace this definition over here. Because we already said struct sister. We can keep saying the same name times and nothing will be a problem, as long as they're all consistent. And then we would have brother. You have a sister pointer. So that's the circular inclusion problem, is where one thing needs to refer to the other before the next. And the way that you resolve that is by putting the forward declarations there. One thing to note is that if all you have is a forward declaration, you can only have a pointer to that thing, a reference to that thing, or accept an instance of that thing as an argument to a function in a function declaration. You cannot have an instance of that thing with only the forward declaration. You need the full-on type specification of what it's going to be. So what we could do is we could, if we wanted to, like eliminate over here in the .h the fact that we need to include sys.h and just have the forward declaration in the .h file, and that's fine. But then over in row.c, in addition to including row.h, we would also, in our C code that probably needs to use something about the sister, we would need to include sys.h as well. So I have the full definition of what a sister is able to access. Otherwise, the compiler doesn't know what makes it. So you might be like, well, where is this going to happen in real life? I want you to be forewarned about it. Like, for example, in one of the future games we're going to have, like a player, like think about for like Monopoly game, which we did in the past, right? A player has properties, right? But what you might also want to know is who is that property's player, right? You might want to ask a property who their player is, who's their owner, right? And so now I have this circular inclusion. Player, know about properties, property has to know about player. And they have to be resolved with a forward declaration. A lot of times when I'm doing this, I kind of go under the principle of if I'm made up of you, I will include you in terms of trying to resolve these circular inclusions. But if I only refer to you, I will just have the forward declaration to resolve. This example of the player and the property. Player would include the property. Player has properties, it's made up of them. But the property only needs to refer to the player. Just have the forward declaration to break the circular inclusion problem. Player.h. Yeah, player.h would include property.h. Player.c would include player.h and property.h. Property.h forward declared player. Property.c include property.h and player.h, right? Because notice it's okay for the .c files to do the includes of everybody they need, because you don't include C files, you only include H files. So I know some of you guys had issues last homework about including the .c's and read lines. Don't include .c or .z, .h. Anything else? Yes. Correct. So property.c needs to include property.h because the property.c code needs to know what a property is made up of to be able to do its work. That makes sense, right? Property.c also needs to be able to know what a player is made up of to probably be able to access any of the player members, able to access any of the player's members. So inside the property.c code, I might refer to a player and need to be able to access some portion of that player. If I want to be able to do that, I need to know what a player looks like. Find out. Anything else? A really annoying advantage of the topic that you have to deal with. It really comes up when you're working on problems. So we've done that, we've done that. Let's also have questions on structs. What would you like to know more about structs? Is it how to define them? Is it when to use them? Is it how to pass them to functions? Is it how to return them from functions?
About structs. Oftentimes after the last curly bracket.
Yeah. And so display one screen down.
We're at it. Type def
Struct. Okay. So over here on like line 10, we have defined a structure to represent our board. And so one of the questions you might have is, when do we want to use structs? You want to use structs when you have multiple things that represent one logical idea. For example, like a car has an engine and wheels and rims and a steering wheel and seats, right? These things all logically together make one thing called a car. And so you might want to represent that inside your computer as one logical thing, a car that's made up of many different parts, right? And it keeps it nice and organized with all those related members together. Just like here, my board is made up of the actual 2D array of characters, and then the number of rows and the number of columns, and what character represents the blank character. All those things taken together make up a board. Individually, they're not so useful, but together they're very powerful. So it's a way of collecting them together. This thing over here is actually, this part over here is actually two things. There's the struct declaration, which is this part right here. And there's the type def, which involves type def keyword, the first type, and then the new type name. So I might want to do something like type def, an int as a phone number, right? And now phone number is just another name for int, but it provides us a much better idea of what the type of that thing is supposed to represent. It also makes it easier to update your code in case you decide, well, an int is not a good way to represent a phone number. You can just go change this type def, and if everywhere else in your code you use phone number, you change it to the new type, everything just works. Okay. Unless there are some differences about that type. Just a second. So now everywhere I say phone number, it's just the name of an int. This portion right here defines my struct. I'm creating a new struct. I'm giving it its name as board underscore struct. The underscore struct is just my own personal convention. You don't have to do the underscore struct part. So the name of this struct is actually board struct. And these are the members that make it up. And then with the type def, I'm saying I want to define this type as just board. So now board means struct board struct of all these things. So in general, now that I've defined it, instead of saying board, I can say struct board. That's the same thing as saying, or struct board underscore struct. This is the same thing as just saying board, or board is another name for just saying struct board underscore struct. So it allows me to type a lot less, because if I don't do the type def, I have to keep saying struct board underscore struct every single place I want to use that board struct. So save some typing convenience. Does that make sense? And then someone had a question right there.
Yeah.
I wouldn't recommend doing it. And in general, the reason that I have this type up here, because you could get away with just leaving it blank altogether, is if you need to be self-referential, like you want to be able to refer to your own type, you have to use struct, board struct inside of it. For example, like a person might have siblings. Your siblings are other people, right? So I need to be able to refer to my own type, but the only symbol that's been defined is this symbol right here. So I have to say like struct, board struct, pointer, siblings. Any other questions about structs, like how to pass them to functions, how to return them? So sure, right? So a function can either accept a instance of that struct, or it can accept a pointer to the struct, or just like everything else, you can have an instance of it or a pointer to it, right? You can have an int and an integer pointer. If this function right now it's accepting a board, it gets a full-on copy of all the members. But you need to be careful about what a copy actually means. When I copy the members over, I copy over the character pointer, then the integer, and the character. Notice the space for the board, it's probably been dynamically allocated and is somewhere else. So now my copy, it has a pointer to the same location in memory of where these characters are at as the original board has. So if in my copy, I go and I modify the characters inside of its board, right? The original will also see the changes because I copied the pointer. So be careful about that. So if I have an instance of the item and I want to access its members, I do dot, right? So if I have the struct, like an instance of it, I do dot. So board.num calls, board.num rows. If I have a pointer to the thing, right, and I want to be able to access its members, first I have to dereference the struct, right? And then dereference the pointer, right? And then access the member. So here, if I wanted to access the board's rows, I'd have to do something like star board.num rows. Right? That's pretty cumbersome to type. So I can do board arrow num rows. And so num rows is just shorthand notation for dereference the pointer and then access the member. So dereference board, dereference that pointer, and then access its member num rows. Right? This is annoying to type because you're going to forget the parentheses, I guarantee it. And so it's just a nice notational convenience. Does that make sense? Any other questions about structs? Yes. So when you create a copy of the board, you create a copy of the members, right? And so the only members here are the character double pointer, the two integers that make up the rows and columns, and then the character that represents the blank character. So when you make a copy, right, you just copy over these values, right? But remember, like the space for the actual 2D array of characters has been made somewhere else, right? And this guy over here, the board, actually just holds the address of where that thing is at in memory. So when I make a copy of it, the copy now has a pointer to that same address in memory as the original does. So if I go to that address in memory and I modify some of the elements that are there, that's at that one location. So both the original and the copy would see the changes. Does that make sense? Yeah. Anything else about structs? So the question is if you passed in an instance, like a copy of the board, as opposed to passing in a pointer, would you be able to modify num rows, num columns, and the blank character? You could modify the copies, of course, because you didn't declare it as const, but it's only going to modify the copies. Also, if I did something like in the copy, I said like the board equals null, that changed copies. location of memory of where it was pointing to. Didn't change the original, so I wouldn't actually change where the original is pointing to. Anything else? So could a board contain a pointer to another board? Sure, I guess it could. I mean, like if you wanted to do that, you would want to do something like struct board underscore struct pointer me, right? And then after you create an instance of it, you could say like me equals the address of, you know, like whatever the instance of that board is, me's equals the address of the board. And that would work, but be kind of weird. And it would also be like a little bit suspect. And you'd have to worry about like things being like on the stack and then being returned later, because then it's probably actually copied to a different location on the stack. And you could do it, but, and like the C++ classes actually do have something like this. It's called this, and this is a pointer to yourself. Just like if you've ever worked in Python with classes, there's the self. Self refers to yourself. This refers to yourself as well. Okay, we still got 4 more minutes. Okay, I think the next topic was containers, unless you have more questions. So what were your guys' questions on containers? Iterators? The iterators, yeah, sure. Or maybe we had an example back down here. So let's say we focus over here on dot product. So an iterator just is like basically a reference to something inside the container, some position inside of it, or so some element inside of it. So I have iterator 1 is equal to the beginning of vector 1. So I want to iterate to the beginning of v1, but I also want it to be constant because I'm not planning on modifying it. Iterator 2 will point to the beginning of vector 2, but also be constant. I don't want to modify it. Cool so far. So I want to keep going while the first iterator hasn't reached the end of the first vector, and the second iterator hasn't reached the end of the second vector. Plus pluses go to the next thing. To access the member that the iterator is pointing to, you dereference it. Do you want more? Is there still? The syntax might look weird, and then the auto here just saves us from having to do something like std : vector bracket int : const iterator, which is just so long to type. I'm like, just auto. Use autos with iterators. It saves you a lot of time and it will make less mistakes. Any other questions about containers? Yeah. Correct. So it's kind of like a pointer, but a little bit different, but mostly a pointer. Anything else? Because you can say it's a pointer that knows how to get to the next thing. Yeah. You'll probably like use mainly vectors. You might use some maps for some upcoming homework, but like in general, right? Like our for loops before have been like for I equals 0, I less than the length, plus plus I, right? If you wanted to go through everything. If you don't want to go through like, if you want to be like your code to be a little bit more robust and generalized for whatever container you're going through, you would use iterators like you're doing here to say go through each thing. They're also useful if you need to know like the position. If you just want to go through the thing like you would do in Python, like, you know, for element in like list, you can use this syntax over here for the type of the item in the container, right? You can read the colon as in. So it's like for item in container, but you have to give the item's type. Unlike in Python where you can just say for element in iterable. And so here, the type I'm using is const auto reference, a reference to the item that I cannot change. I will see you guys in class. If you have questions, feel free to stop by up here.